What do we mean by the universal law of gravitation being an inverse square law? And what is the meaning of that squared on that distance between the centers? So let's say we've got two objects, and at first they were at a certain distance r away from one another. Let's just decide and say we're going to double that distance. So very quickly, now the value of r is going to be twice the original value, 2r. That means that this value here becomes 2r. And remember, all of this value is squared. So that is the same as saying 2 squared times r squared. And we all know that 2 squared is 4. Initially the force was at gmm all over r squared. The force had this particular value, whatever that value is. Let's say we've worked all of that out, and that turned out to be 100 newtons. Now when we're introducing a 4 in the denominator, that is the same as saying we are introducing such a fraction on the right hand side. And that means that the original force, which was 100, will now be 1/4 of its original value. If we double the distance, that means we're going to get 1/4 of the original force. If we triple the distance, that means we're going to get 1/9 of the original force. Why? Because that 3 in the denominator here is going to be squared. 3 times 3, that's 9. And we can continue doing this. I mean, if we quadruple the distance, we're going to get 1/16 of the force. So what this actually means, when you've got an inverse square law, it means that the force is not going to decrease in a directly proportional manner, but rather, had I had to sketch a graph of force in newtons on the y-axis against distance away from the surface of Earth, this being the radius of Earth, okay? So we're seeing what's going to happen. So this is the radius r. So if we're going to plot what's happening from this point outwards, okay? So if we plot that at the surface of it, it's going to have a particular value, whatever that is, but the effect of an inverse square law means that this won't fall off proportionally, but rather it would take a more drastic decay, with the x-axis being an asymptote.